Alright, rational functions. So we have f of x equal to n of x over d of x. N of x and d of x are just the functions that your book used, so I just stuck with them to be consistent. So they are polynomials, and of course the denominator can't be equal to 0, so the denominator cannot be 0. Whenever we have rational functions, there's something called asymptotes that could happen as a result. One of them is a vertical asymptote, meaning it's going up and down. Like that. And what they do is it's a line that never touches it. So, and we know it's a vertical asymptote. Let's say we have x equal to a. We know it's a vertical asymptote when f of x goes to infinity or f of x goes to a negative infinity. As x approaches a from left or right. So at a given value a, make that a, if the graph is starting to go to positive infinity or negative infinity from both sides, you're going to have a vertical asymptote. Then we have horizontal asymptotes. So horizontal asymptotes are written as y equals. Vertical is x equals, because horizontal is when it's y equals, it's literally a whole horizontal line. So it's y is equal to b when f of x approaches b, meaning when the output is getting closer and closer to that b value as we go to infinity or negative infinity. So as we go to, if we have a horizontal line, we'll call this b. As we go to infinity, it might be coming all the way up from up here and then getting closer and closer to that b value, whatever that may be as an output. And then same thing from negative infinity. I'd start here, and then as it goes to negative infinity, it gets closer and closer to that b value without touching it. Alright, so let's say for this rational function we have this polynomial function up here. I didn't write it all out, but let's just say it's this polynomial function for the numerator and denominator. What these represent, though, these are both the highest power in the numerator and the denominator respectively. So m highest power n highest power. Okay, so when I say highest power, I mean it's the highest power. N is the highest power in the whole numerator, and m is the highest power in the whole denominator. Now that's going to be relevant for when we try to talk about what the HA is. First, VAs, vertical asymptotes, are just values that make the denominator 0 but not the numerator. Okay, so if it makes the denominator 0, that value is, in fact, a vertical asymptote. Now in HA, there's 3 different scenarios. They deal with the powers, okay? If the n is bigger than m, meaning the highest power is in the numerator, it's bigger than the denominator, there is no HA. No HA. If the power is higher in the denominator, meaning m is bigger than n, the HA is y equal to 0 automatically. Okay? Y equal to 0, write it down, you got it. And then if they're equal, n is equal to m, then it will be y is equal to the coefficients, meaning a sub n divided by b sub n. Okay? So that will be your horizontal asymptote. We just look at the coefficients. Number in front of the base and the highest exponent in both numerator and denominator. Okay? Cool. Alright, let's find the HAs and VAs of this. We need a factor where needed, okay? So I don't want green for that. So we will get x minus 1 times x plus 1. And the power is higher in the numerator. 3 is bigger than 2, so there's no HA. Is there a VA? Yes, there's 2 of them, right? There's 2 values that make the denominator 0. It's x equal to 1 and x equal to negative 1. For the other one, we got 2 factor, x minus 5 times x plus 5 over x minus 5 times x plus 1. Now you might be inclined to say, well, first let's do the easy part. Let's say powers are the same, both 2 and 2, so it's going to be the coefficients, which is 1 over 1, so your HA is y equal to 1. Now as far as the vertical asymptotes go, there's only one, and that is x is equal to negative 1. Why is that the only one? Well, because when you have a factor that's the same on both the numerator and denominator, that's not going to be a vertical asymptote. That's what's going to be called a hole. Okay, so therefore it's still going to be affected in our domain, right? The function cannot be equal to 5. This function right here, up here, can never be 5 because it makes the denominator 0. But it is not a vertical asymptote because it cancels out with the numerator, making it a hole, not a vertical asymptote. Alright, so we're going to sketch the graph of this rational function here. So first let's factor. Your book has some interesting strategies on how to graph a rational function. They give you a step-by-step process. If you want to go for that, sure. In so many ways, I kind of do the same thing, or at least I get to all the same things. One of the easy things to do right away, and I think your book has, this is one of your first steps, and this is to find the y-intercept. Why is that easy? Because all you have to do is set all the values of x equal to 0. So that's 0, that's 0. Giving you 4 over negative 4. So your y-intercept is 4 divided by negative 4, which is negative 1. So the y-intercept is 0, negative 1. How about the x-intercept? So when we factor the numerator, so we have 2 x-intercepts as a result that don't make the denominator 0. Key, don't make the denominator 0 either, or else it's not an x-intercept. So 4, 0 and 1, 0. Now let's talk asymptotes. So values that make the numerator, not numerator, denominator 0 are going to be your vertical asymptotes, right? So that's 2 and negative 2. Right? And then your HA, label them x equal to 2, x equal to negative 2. Your HA is going to be 1 over 1, which is just 1, so it's going to be y equal to 1. Okay, so let's see what's happening in between here. I'm curious about some of these things. So we have y equal to negative 1. We have x-intercept of 4, 0 and 1, 0. Interesting stuff coming on here. So next, as your book states it, they say plot at least one point in between x-intercepts and asymptotes and 1 point beyond. Okay, so 1 point here and 1 point over here, that would usually help. So that 1 point there is a 3. So when x is 3, what happens? It's easier when we use the factors right here, right? So when x is 3, we get negative 1 times 2, which is negative 2. And then 3, so we get 1 times 5, which is 5. So negative 2 over 5. So we're somewhere down here. And then 1 point beyond, let's pick 5. So that's going to give us a numerator of 4 and a denominator of 3 times 7, which is 21. So a little bit above it. Right? So it's going to be one of these. And over here, let's go in the middle here and negative 1. What do we get? Negative 1 will get negative 5 times negative 2 over 1 times negative 3, giving us, let's see, that's going to get us a 10 over negative 3. 10 over negative 3, that's going to be about a little over negative 3.5, so somewhere over here. What happens in between here from between 1 and 2? So we do 1.5. I'm interested if it's positive or negative. I'm not going to get specific. So it's going to be a negative times a positive over a negative times a positive, giving us a negative or a negative, which is positive. And then if you do any more points, it's going to be a little above it. And then it's going to shoot up. Okay. Now you're probably thinking, why is it? I thought it was a horizontal asymptote. Why is it going through it? Well, it is because the important thing about horizontal asymptotes is it can technically touch it. But the key part is, as we go to infinity, like this part right here, as we go to infinity, it's getting closer to 1, but never going past it. But as we go to negative infinity, it'll be similar. So let's pick up some points as we go to negative infinity, so somewhere less than -2. Let's say -3. -3 will get us an output of 5.6. So with that said, it's going to be somewhere over here, 5.6, somewhere above. So we're going to be living up here. Okay, and there's the graph of that function. All right, so when it's a little simpler. So we have this function right here. So same story. Y-intercept would be put 0 in for x, and you can output a -1/4. Cool. So x-intercepts there's none because no values make the numerator 0. Also, HA. Power's higher in the denominator, so it's y equal to 0. And values make the denominator 0 is just x equals -4. So let's draw what we have so far. So we have y equal to 0 as a HA, VA, -4. And then from there, we have y-intercept of 0, -1/4. So it's going to be like right there, giving us a graph that's going to do one of these. And then in the top corner here, as x gets more negative, we'll do something like that. We pick a point. Let's say we picked -5. -5 will get us an output of +1. So -5, 1 will be right there. Okay? That was a little simpler than the last one. So we got the original function here. So this is going to be following our what is a slant asymptote. We're going to talk about slant asymptotes in this one. Okay? This is whenever we don't have an HA. Okay? Power is higher in the numerator. Okay? But I want to find out the other stuff first. Okay? So what I did was I factored the denominator, and we have 2 VAs. Here we go. We have a y-intercept of 0, 0, which is cool. And then let's divide. So we have 2x squared minus 8, and then x cubed inside. This is not a pretty one, folks. I'm sorry. But in order to find this slant asymptote, what times 2x squared will get us x to the third? That'll be 1/2 x, right? Because 1/2 times 2 is going to get us 1. So it's going to be x to the third minus 4x, giving us, so you subtract it. Therefore, you're going to get 4x for your remainder. I'm going to put that there and then add plus 1/2x. Okay, so what does that tell us? This right here is your slant asymptote, okay? So it's going to be, so let's draw that. It's going to be, so 1/2 is going to be somewhere around there, right? With the 1/2 slope. And once again, just like with the horizontal, it might touch it at one point, right? But we know that as we go out here, meaning out to infinity and negative infinity, it's going to be doing something different. So let's plot some more points. Let's say we have what's happening between here. If you were to plot 1 and -1, it's going to be one of these values that look like this. Okay, it almost looks like an x cubed graph, right? It's in between there. And if we pick up a couple points beyond, like 3, if we put 3 in, that'll get us 27 over 2 times 5 times 1, which is 27 over 10, which is a little over 3. So, somewhere around here, we'll call that, we'll move it over a little bit. And then it'll just keep extending out to here. Similar over here, if I put -3 in, I'll get -27, and then For the denominator, I'll fix this up. It will be 2 times -1 times -5. So it's going to be a 10. So somewhere around here again, and shoot around there. Okay? Appreciate you watching, and we'll see you in class.